All right, Math 2, here we go. We got lesson 13-2, volumes of pyramids and cones. So our question for today is, if a prism and a pyramid have the same base and the same height, what's the relationship between their volumes? So this is kind of an important distinction between the two. Remember, a prism has two bases, so like they'd have a rectangle or square on the bottom, and then they'd have another one sitting up on top, and then they're connected by parallel sides. And so we saw that we could take the base area and multiply by the height. Now this question says, what if we've got a prism, and then over here I've got a pyramid, and they've got the same heights, but in a pyramid, instead of having a base on top that looks the same, a pyramid comes to a point instead of having a base on the top. And there's some relationship between those two. Hopefully you'll see what it is right now. So when we have a pyramid, we're still going to do base area times height. So remember, what we're doing here is we're taking the area of the base, and then we're just stacking it on top of each other and seeing how many cubes we can create with that. So it's the base area times the height. But instead of a prism where we can just keep on stacking till we get to the top, each time we stack, we get less and less and less because it comes to a point instead of just going straight up. So this square on the bottom, or rectangle, or whatever we have on the bottom, gets smaller and smaller and smaller as we get to the top. So we have less and less area as we keep on going up there. So our question today is really related to what is happening with the volume as we do that. And here's what's happening. We're losing 2/3 of our volume. So we're keeping 1/3. So anytime that you come to a point, you're going to lose 2/3 of your volume, or in this case, we're going to say that we just keep 1/3. So we're still going to do base area times height, but we're only going to have 1/3 of that because we're coming to a point instead of going straight up. Whereas if we went straight up, we'd still have a lot more volume out there. Okay, there's a couple things that we need to look at. When we've got height, height is always perpendicular to the base. So wherever we measure height, it has to be perpendicular to the base. So the height of a pyramid is inside the shape, whereas the height on a prism was outside of the shape, on the edge of the shape. The other thing that we've got is another thing called slant height. Slant height goes from one edge to the point where all the sides are coming together. And it makes, we can see it's making here a little right triangle going this way. This is called the slant height. So sometimes they're going to give us the slant height and not the actual height. But if you look here with this dotted line here, and then this part down here, this is a right triangle if we connect it with the slant height. The slant height would be the hypotenuse. So if you're given the slant height and you know this bottom portion, you can use the Pythagorean Theorem to find the actual height right here, the height of the pyramid. So remember, we're going to do base area, so base times height of the bottom part, or the base. And then we're going to multiply it by the height of the actual pyramid, which is inside. And then it's always going to be 1/3, because when you come to a point, you lose 2/3 of your volume and you're keeping 1/3. Same thing with a cone. A cone is very similar to a cylinder. Whereas if we would have a cylinder like this, we'd have a circle on top and a circle on the bottom. But in a cone, instead of going straight up, we go to a point. So we're losing all of this volume over there. And so again, since we're coming to a point, we're only keeping 1/3 of the cylinder's volume. And so lateral height or slant height on this one is going to be here. Slant height. I forgot to write that down, but sometimes it's called the lateral height. And usually cursive L is used for the slant height. So that's a cursive L right there. Then that's just to distinguish it from the actual height. So over here, our height again on a cone is perpendicular to the base. Now, since a cone is kind of like a cylinder, the base area of the cylinder is always going to be pi r squared. Whereas the base area of a pyramid, well, it can be just about anything. You can have a triangle on the bottom. You can have a hexagon on the bottom. You can have a whole bunch of different shapes on the bottom. So the base area formula depends on what the shape of your base is. All right, so let's look at our first problem here. We've got a square pyramid. Now the part that says square means that this bottom is a square. So that means if this is 10 here, this side must also be 10, and so is that side, and so is that side. Okay, it looks like on this one, we've got a base length of 10, and the slant height, or the lateral height, is 13. So that's our lateral height right there, slant height. And we want to find the area of the base. Well, they say the base is a square, so the base area would just be 10 times 10. So we've got 100 right there for our base area. To find the volume of the pyramid, we've got 1/3, because remember when you come to a point, you lose 2/3 of your volume. So we only have 1/3 left. So 1/3 times the base area, and we've already identified the base area is 100 units for this one, and then times the height of the pyramid. This is the height right here. Now we got a problem. We don't know the height, but we know the slant height or the lateral height over here. So what we can do is use the Pythagorean theorem in this triangle here, where I've got 5 here, h here, and 13 here. So we can use the Pythagorean theorem to find the actual height. So we would do h squared plus 5 squared, and then the lateral height's the hypotenuse of this, so that's 13 squared. So this would give us h squared plus 25 equals 169. Subtract 25 from both sides, we get h squared is equal to 144. And so h is 12. So now we know that we have a height of 12 there. So now we're ready to fill everything in. Our volume is going to be 1/3 the base area, which is 100, times the height, which is 12. So this is going to be 1/3 of 1200, and then 1200 divided by 3 means that we're going to get a volume of 400, and this is in inches cubed. All right, so remember, you have to find this height, and usually to find that height, you're going to use the Pythagorean theorem. All right, next one. Example 2. Find the volume of this solid. So this solid looks like a combination of a couple shapes. Looks like we've got on the bottom here a cylinder that's topped by a cone. So when we have a compound shape like this where it's got several different shapes inside of it, we're just going to take individual pieces and then add them together. So I'm going to take the volume of a cylinder and add it to the volume of the cone. Okay, so remember the volume of a cylinder is base area times the height. The volume of a cone, 1/3 base area times the height. Okay, so let's look at the cylinder first. Well, it gives me the diameter here, but for base area, since this is a circle on the bottom, we're going to use pi r squared. And then over here, since the cone also has a circle as its base, the base area is pi r squared. All right, so we need r and we need the height. So r over here, the radius is going to be 3. So this is pi times 3 squared. And our height over here, the height of the cylinder, looks like it's 8. So this is 9 times 8, which is 72 pi. So that's the volume of the cylinder, and we're going to add the volume of the cone to that. So in our cone, it looks like we also have a radius of 3 here. But this time, this is the lateral height over there. We need the actual height on the inside. So we're going to do 8 squared plus 3 squared equals 5 squared. So this is 9 and 25. You probably, if you know your Pythagorean triples, you'll know that we should get an h of 4, which is our height. So the height is going to be 4. So let's go ahead and finish this one off. We got 1/3 pi, r is 3, and the height we found in here is 4. So this is 9 times 4, which is 36. And 1/3 of 36, so 36 divided by 3, that's going to be 12 pi. So I've got 72 pi plus 12 pi. That's a total of 84 pi's. And this would be in centimeters cubed. So this is the answer in terms of pi. If you want the answer rounded, like sometimes we round to the nearest whole number or something like that, we might take our calculator and just do 84 times pi. Now, if you've got a calculator like this, sometimes it just leaves it as 84 pi. These calculators will have this button that has these 2 arrows pointing side to side. That's going to give you your approximation or your decimal answer. So I'm going to click that. And it tells me that's about 263.89. It's obviously not exact because pi, you can't write down the number. So we're just going to round that to the nearest whole number. Okay, so that's going to be 264. So this is approximately 264 centimeters cubed. All right, there you go. So the big difference between a prism and a pyramid, if they have the same height and the same base, there's going to be a difference of 1/3. So the pyramid will always have 1/3 the volume of a prism that has the same base and the same height. All right, that's all I got. Math hard. See you guys. Bye.